Now we're going to talk about triangles. And we're going to talk about a Greek philosopher named Pythagoras, who discovered a very interesting thing about right triangles. We love right triangles in geometry. Here's a right triangle, and what he discovered, if you see this triangle, this leg has a length of 3. If we square it, we get 9 square units. This leg has a length of 4. If we square it, we get 16 square units. Well, what Pythagoras discovered is that the square of 3 plus the square of 4 has to equal the square of this side, which happens to be 5. That is a really useful tool in geometry. In any right triangle, the sum of the square of the legs equals the square of the hypotenuse. Need to know the terms. These are the legs, they form the right triangle. They're the two shorter sides. The hypotenuse, which is this one right here, kind of a funny name. The hypotenuse is the longest side of a right triangle, and it is always the side opposite the right angle. So the Pythagorean theorem states, in a formula way, a squared plus b squared equals c squared. A and b, lowercase, are always our legs. C is the hypotenuse. Now let's put it to use. If we want to find the length of a hypotenuse on a triangle, we can use the Pythagorean theorem. We have a triangle. Please make sure you draw your triangle with a 15-inch leg and a 20-inch leg. And we're looking for the hypotenuse, which we will call lowercase c. We're going to start with the theorem. Please put your formula down, use direct substitution, and put the values in. We evaluate that. We get 225 plus 400 equals c squared. C squared equals 625. We take the square root of both sides, and we come down to a c of 25. And that's going to be inches. Not so bad. Let's move on to a practical problem. You're parasailing. You leave the boat, you have a 300-foot tow line, and you end up here. Well, you're 200 feet from the boat laterally, straight out. So how high up are you? That's what we want to find out. We've labeled that leg B. So you see our right triangle? We've got 200 feet, and B are my legs. The tow line is the hypotenuse. We put down our formula, plug in the numbers, evaluate those squares, and we're going to come out with approximately 224 feet above the water line. So the answer is B. Now, here's 2 triangles for you to try. I'm going to come down here, okay? Once you use the Pythagorean theorem, C here equals 19.5 inches, and C here is equal to 12 feet. I'm not going to take the time to go through them. I want you to practice them on your own. What you see is that A, B, and C here are 9, 12, and 15 feet. These are 18, 7.5, 19.5. Well, we love when those squares come out to, the square roots come out to integers. And this has a special name. When all 3 sides are integers, it's called a Pythagorean triple. This is only on a right triangle, of course. And our most common Pythagorean triples that we like to work with, or the ones that are most common to memorize, are the 3, 4, 5 and the 5, 12, 13. So if you have a triangle where the legs are in the ratio of 3 to 4, the hypotenuse is going to be 5, and any multiple of that. Notice that the 9, 12, 13 is this triple times 3. So that is also a Pythagorean triple. All 3 are integers, and it makes a right triangle. That's a very special case, which we can prove with the Pythagorean theorem. Couple more things to talk about here with the Pythagorean theorem. The theorem states, the theorem is actually a conditional statement. If a triangle is a right triangle, then a squared plus b squared equals c squared. Well, every conditional statement, otherwise known as an if-then statement, has a converse, which essentially is the theorem backwards. Sometimes the converse of a statement is true, and sometimes it is not. In this particular case, the converse would say, if a squared plus b squared equals c squared, then the triangle is a right triangle. And in this particular statement, the converse is true, always. So we can use that to prove if a triangle is a right triangle. So let's look at two cases. We have given a triangle with sides 6, 8, 10. Is it a right triangle? Well, we're going to use the converse of the Pythagorean theorem. We're going to plug it in. If it comes out true, then we're going to draw the conclusion that yes, in fact, it is a right triangle. And that one works. Let's plug in this one. A equals 10, B equals 12, and C equals 16. We're going to plug that in. Does it come out to a true statement? No, it does not. Therefore, a triangle with sides 10, 12, and 16 does not make a right triangle. And that's all I have for you on the Pythagorean theorem right now.